Hi guys, and welcome back. Now that we've kind of explored how the CoreDNS component is set up on our Kubernetes cluster up in Amazon Elastic Kubernetes Service, and now that we've understood how the configuration for CoreDNS, also known as the core file, has been mounted into the CoreDNS pods, let's actually test out DNS resolution against CoreDNS and play around with it. So I'm going to go ahead and create an interactive container on my Kubernetes cluster. And so we'll run a kubectl and we'll use the run command. And if you take a look at the help for the run command, this allows you to actually spin up a pod on your Kubernetes cluster, and you can actually make it interactive so you can see the output from the container on your local system, even though the pod's running up in the cluster. And you can also make it interactive so you can type commands and send them into the remote pod. So what I'm going to do is use the standard in, and the TTY parameters. That's what's going to enable it to be interactive. And then we're going to need to specify a container image that we want to use to spin up an interactive pod as well. And we also need to specify a name for the pod. And once we do that, we should be able to interact with it. Of course, we also need to specify a command that we want to run in the pod. And we could just run a bash shell, for example, in the pod, and that should allow us to, type interactive commands and, basically run whatever we need to inside of there. Now I'm going to be using an Ubuntu base image for this purpose. So if you head out to hub.docker.com and you take a look at the Ubuntu image out here, this is just a really nice general purpose image that's good for troubleshooting because it has access to the apt package repositories for Ubuntu. You can install all sorts of utilities on it, and you've got a lot of choices about which version of Ubuntu you want to run on there. And so I'm just going to be using the latest LTS version of Ubuntu. I'm not sure if 2204 is released yet. I don't think it is, so I'm going to use 20.04, and that'll be the base image that we use to launch an interactive container. Let's run a kubectl, and we'll say run, and then we'll specify our image as Ubuntu, and then I'll say 20.04, and then we'll go ahead and do standard in and TTY, and we'll do a name for the pod. So I'm going to call this interactive pod. You can name that whatever you want to. And then I'm just going to put a double dash here, and then after the double dash, we'll specify the command that we want to run. I'll just say bash, and that should create a pod on the remote system. It can take a second because it has to download the Ubuntu container image and spin up a new pod from that container image, and now you can see that we've got this interactive pod here. You can also fire up another terminal, so while that's running, I could go ahead and just SSH into the same server, and I could just run a kubectl get all from the default namespace. And you should see that we have a pod right here named interactive pod. It's currently in the running state. And so everything looks pretty healthy there. So you could do a kubectl describe on that, and it'll basically show you the configuration of the pod that we just spun up interactively right over in this window right here. So we can basically verify that it is sure enough running on our remote cluster. All right, so inside of this container, inside of this pod that we just spun up using the Ubuntu base image, I'm just going to run an apt update here, and then I'm going to do an apt install on the DNS utils package. And let's do apt install DNS utils -- yes. That should install the dig utility, and we can use the dig utility to basically just issue DNS queries against our server. Let me just plug in geography here, 12 for US. I'll just plug in 1 for Alaska because I don't really care about that. But now that I've got DNS utils installed here, I should be able to run the dig command, and we can use dig to basically query DNS servers. And let's see if we have NSLOOKUP, and sure enough, we have NSLOOKUP as well. And if I was to run NSLOOKUP against github.com, you can see that the server that is responding here is actually 10.100.0.10. So if I run a kubectl get all on the kube system namespace here and take a look at the results here. So we've got our CoreDNS pods, of course, that we've already looked at in that namespace, but check it out. We also have this service controller here called kubeDNS. And this kubeDNS service, which is essentially just an internal load balancer resource, has an IP address on the cluster's internal network, and that IP address is 10.100.0.10, and it is forwarding traffic on TCP and UDP port 53 right here. And so this IP address right here is exactly the same IP address that you see right over here when we run NSLookup. So the server, which is really just a load balancer, a service resource in Kubernetes, is the IP address of that server is basically the same as the service that we have right over here called KubeDNS. So this is actually just something that's kind of interesting to note, is that the service controller, the load balancer internally, for DNS specifically, still has the legacy name of KubeDNS. However, because CoreDNS has been switched out in favor or in deprecation of KubeDNS instead, the CoreDNS pods are going to be responding to the actual requests, but the service controller itself still has that old name of KubeDNS. I'm not sure if they're ever going to update that to coincide with the new CoreDNS, but if you are looking for the DNS load balancer, it is going to be named KubeDNS internally to your Kubernetes cluster. So that's just something that you'll kind of want to be aware of as you're administering a Kubernetes cluster. So we can see that these DNS requests are actually being correctly forwarded from CoreDNS out to the external servers, DNS servers rather, that are configured on our cluster nodes. So something else that we could do is actually attempt to resolve an internal service here as well. So if I take a look at my default namespace, so let's do get all on the default namespace here, you can see that I've got a couple of service controllers or load balancers here as well. One of them just has an internal IP address of cluster IP. The other one is actually being exposed on a node port as well, but it also obviously has a cluster IP for internal use as well, if there's pods that want to hit it. And so let's say that we wanted to discover the service called myCBTNuggets service. Well, what we can do is actually run NSLookup against that name, and we'll be able to resolve it by using just that name. So let's do an NSLookup, and I'm just going to paste in myCBTNuggets service. I just realized that I was actually running NSLookup in my interactive NSLookup shell here. So the reason that I was having that failure is actually because I was running NSLookup inside of this interactive NSLookup command right here, and so it was failing to look up NSLookup, which obviously is not going to resolve on my cluster here. So if all I can do here is type in myCBTNuggets service, and as you can see, it automatically adds in the cluster's suffix here. So it's going to plug in the namespace that the service belongs to. So this service controller belongs to the default namespace, as we can see in the output of kubectl get all on the default namespace right over here. On default, you can see that that service resource belongs to that namespace. And so then after that, it's going to add on a suffix of .svc.cluster.local. So anytime that you are resolving a service or a pod inside of your cluster, the suffix is going to be the namespace name after the service name, of course. And then you've got just .svc, that's just a literal kind of referring to the service resource type. And then it's going to also require you to specify the cluster's DNS name, which in this case is just .cluster.local. And so now you can see that we get back the address of 10.100.191.3. And if you take a look at the IP address of this service controller right over here, sure enough, that does match up. Now, at this point, what you could do is, in order to test out, that we are truly resolving against CoreDNS right here, we could actually tear down CoreDNS entirely on our cluster and effectively break it, and then see what happens from a client container that's attempting to resolve these different DNS names. So one of the things that we can do to kind of intentionally break CoreDNS is to go back into the kubesystem namespace here, say get all. And then what we're going to do is look for this deployment controller here called CoreDNS. And what we can actually do is scale this deployment controller from 2 replicas all the way down to 0 replicas. And effectively, that will terminate the pods that belong to the replica set. it'll tear down these two pods right here, and then we won't have CoreDNS running internally at all. And then when a query is made against the kubeDNS service here, 10.100.0.10, then basically there's nowhere for that service controller to actually forward traffic to, because these pods would have then been torn down. So if we do kubectl and then scale and specify deploy/CoreDNS, that is our deployment controller right here, and we'll set the replicas parameter to 0, and that's going to be in the namespace kube-system. And if we do that, now we've scaled it. So we'll do a get all again. And now you can see that the deployment has been scaled to 0. Our replica set in turn has also been scaled to 0. And both of the pods that were previously running CoreDNS are now in the terminating state. So now at this point, if I run this command again, they should have disappeared by now. So now you can see our pods in the kube system namespace that were running CoreDNS are now both destroyed. So now the service still remains, but the service does not have any endpoints to send traffic to. And we can actually confirm that by doing a describe on the service. I'll do kubectl-namespace, kube system, and then we'll say describe on this service. And if we take a look at the endpoints property right here, the endpoints is now set to none. I don't think we ran this command earlier, but if we had, you would have seen both pods as being configured as endpoints based off of the target labels under the services selector right here. So the service is basically looking for any pods that have a label of k8s-app equals kubeDNS, and it will send traffic to those as endpoints down here. However, we've destroyed the CoreDNS pods, and so now there are no pods that match this selector. So if I come back to my client pod here running the Ubuntu image, and I just hit up arrow and try to run this DNS query again, well, guess what's going to happen? It's going to try to send the query over to the service controller's IP address, but the service controller has nowhere to send that traffic, and the query will simply time out because no servers could be reached. But what we can do to resolve that is to simply scale our deployment controller back up to 2 or 3 or 4 replicas. Let's just do back to 2. That's going to reconfigure the replica set as well as spin up the pods here. And you can see that in a matter of seconds, in fact, even milliseconds possibly, these CoreDNS pods get back up into the running state. So now our service controller should have somewhere to send traffic to. If I do a kubectl describe on the service controller again, you can see that now the endpoints property here for both the UDP as well as the TCP target ports have now been configured to forward traffic to the pods that match this selector right up here. So now if I come back to this pod on the client side and try to run another query internally against the cluster, you can see that that now resolves again. I hope this has been informative for you, and I'd like to thank you for viewing.